Welcome, everyone. Really good to see you guys here, as always. We are going to be treated to, funnily enough, a workshop on coding for a no-code community. So that's going to be an interesting combination, but it's all about helping you be a little bit more dangerous with no code. Just because you have that, or just because you have just enough knowledge of code or JavaScript in this case to kind of inject into your no code project. So Prajot is going to kind of walk us through his learnings and how we can start maybe custom coding from scratch. So yeah, I'm really looking forward to this. He's going to be asking or allowing for questions during this workshop. So we want to make sure everyone is kind of feeling like they're up to speed as we're going and not left behind. So do pop questions in the chat as well or come off mute. And yeah, that's it. So over to you, Prajot.
Awesome. Thank you, Max. I think to start off, the thing on coding, the first thing which is supposed to be known is that coding is hard, and people talk about oh, it takes a computer science degree to become a coder, or you have to scour the YouTube and do so many courses. But that's not true. Coding is actually very simple. It's just you're just basically giving instructions to the computer, and most of it has been abstracted away. uh, Now the bigger problem, which is harder, is problem solving, and that is true for no code as well. Just because you have the tools, it doesn't solve the problem for you. So first thing that I want to be very clear is coding is easy, and it's just basically a little bit of addition, subtraction, counting, and a bit of if else. So that's a very basic gist of what we're getting into. So let's get started. So the first thing is, like I said, programming is all about giving instructions to a machine. So what does this mean? So when we talk about how we talk to each other, or we give instructions between humans, right? So you may ask your brother to go get you a cup of water, right? So there's a code around it, and there are small aspects of the tone you use, and some rules on when you should tell them so they actually get that task done. And with humans, it's much harder because a lot of other aspects come into play. So you are using some sort of a language to give those instructions, and those languages are called natural languages like English, uh, German, or whatever natural language you use. So similarly, you give that instruction to someone, the other person receives that instruction as input. They think about uh, what that words in that sentence mean, and then they decide to take an action, right? So that kind of mental model is pretty much very similar to how we think in coding. So coding is all about humans talking to machines or machines talking to machines, and that third layer is something that we go at the end of the today's workshop. But the main thing that we're focusing on, how do humans give instruction to machine? So there is some sort of input to start with, and that input goes to the computer, which is basically made up of CPU and memory. So CPU is like a brain; it does all the computation on that data. Memory is where your instructions are stored, and all your results of calculations are stored there. So let's say the input is 2 and 3. The instruction is add them, and then when you add them, you store the value of sum 2 plus 3 inside the memory, which is 5, and then that 5 is the output. Right? So that's a very simple model, and then this is the model that is used for coding robots, for coding apps, for coding anything that you can think of. So it's super important to keep this in mind. Uh, and when you think of inputs, that's where a lot of complexity is and innovation is. So your input to any machine could be through a mouse. So I'm moving this mouse. When I click this, what should happen? When I press a button, what should happen? So those are the inputs to my computer. And then my once those instructions enter the computer, and we'll go into those specifics of binary and signals and all of those things later. But what happens is the CPU will store that input somewhere, and then it will run a task of change the slide, and then that output is sent to the monitor, which changes the pixels over here. Right? that's like the mental model that I wanted to focus on a little bit of time, because now when we get into code, this is super important. Uh, and like before we get into coding, the major question is like why JavaScript, why not something else? And why JavaScript is like it's easy to learn as compared to a compiler language like C, C++, or Java. Uh, it has the largest and the most diverse community. Uh, and you can see like the distribution of its popularity. Right now, JavaScript and HTML, CSS are the most popular languages, followed by Python. So it makes a lot of sense to work on JavaScript. Most of the work that you want to do is already been done by someone. So your task becomes like identifying that work and combining all of that together. It runs everywhere, which is like one of the most amazing things about JavaScript, which nobody can compete with, is that on the browser, the language that runs is JavaScript, and all the other languages run everywhere. JavaScript can also run on the server side on your Arduino or your robots or wherever, but that is the only language that runs in the browser, right? And browser is the most popular application that exists. So so if you write code in JavaScript, you can code your entire stack in just JavaScript. So which is why it's like such an important language to know, and it works well with no code. So most no code tools are either around building the front end or the UI, which is like, so Bubble has this whole UI aspect to it. Builder has the whole UI aspect. Software is about UI. Card is about UI. So JavaScript works well with those tools. And yeah, I mean, if you and on the logic side, Airtable uses a scripting language very similar to JavaScript. I mean, they call it AirScript, but it's pretty much JavaScript. So all the no-code tools generally end up supporting JavaScript because they are also built in that. Yeah. So this is like why you should know JavaScript when you're using no-code. And now let's just go to code. No more slides. This is the coding session. Cool. So the first thing is like you need an environment to code in. So there are many options. There is JS Fiddle. There is JS Bin. The one I like is codesandbox.io. So if you just go to this URL whenever you can, and I'll paste this link in, like I'll share a doc after this session, uh, where you can find how to set yourself up and instructions on that. But once you go into this, you get like this screen where you have a src folder with index.js, style.css, and an index.html file outside and a package.json. So right now, the only thing we are concerned with is index.js. Right? So this is where we, like a JavaScript file has an extension of .js, and this is where we'll write our code. And once we write the code, we'll see the output here on the console window. So when you come to this by default, you'll see something like this. But you can click on like this console and then expand it. Right? So is it. I write some code here and the output comes here like magic. Right? Cool. So the first thing, so till now, any questions before we like quickly jump into coding?
I was just going to ask Prajot around, I guess, why is it important for no coders to understand a bit of code, or to understand at least how to write some in the first place?
Right. So that's a good question. So one is like so there are two variables that I think of like about no code. So one is accessibility and the other is flexibility. Right. So no code tools make it accessible for a lot of people to get into building software, but that comes at the cost of flexibility. So every tool is opinionated and they solve the problem in a certain way. And when they do that, there comes a lot of restrictions in what you can actually end up doing. Uh, but they allow you this hook of JavaScript, like you can add custom JavaScript for custom functionality, right? So any application you build ends up needing some sort of functionality which the tool may or may not support, right? So that's where like JavaScript can help you extend that. That's kind of like the first obvious reason why you would go there, to give you flexibility. Uh, and yeah, and the other aspect of JavaScript with no code is like there's this whole space of low code, which comes after you get used to no code, when you have to scale your applications and when you have to get into even more complicated stuff. It's just hard to like scale an app after a time in no code for most cases. Uh, and the third aspect is coding teaches you a way of thinking, right? It's not just about the language or the syntax or something. Learning coding is can be one of the most like gratifying experiences in life at this point. you sitting on a computer by writing a simple some lines of text can send a message across the whole infrastructure from India to US in milliseconds, and like change how people are perceiving that, right? So like just going through that experience once can change your outlook of how the whole uh, like internet and the whole like the information age is working. So code is behind all of that. So I think it's just important to at least know one programming language. Like you know one speaking language, it's just important to know one programming language. And I think that programming language should be JavaScript.
That's awesome. Yeah, thanks so much for that. I love the third point particularly. Yeah, thanks so much.
Awesome. So cool. So we'll get into coding. So the first thing that you need to know, because you're working with the console and if you're outputting data here, so how do you log stuff or print output to the screen? So in JavaScript, it's done through a very simple command called console.log. We'll go into what each of these brackets and syntax means. For now, just like think of this as one thing, console.log. And then you can pass something, a value between these parentheses, right? So I'll pass hello world, and then when I save, it will start showing this here, right? So that's cool. So I'm able to print this value to my screen. Now let's say I want to print a sum of two numbers. So I can just say 1 plus 3, and it will print 4. Right? So by just like doing this, I'm able to print some stuff here. So that's called logging. And yeah, you can just log any value that we have out to a console. So that's one. Next thing is comments. So this is again super important because I'll be going through this a lot. So let's say I do this. I write so it'll show me like this because I've logged it. But now I don't need this anymore. So you can just add double / in front of it to comment that code. And you can see I've commented a lot of the code right now, which I don't want to run. And then you have something called as multi-line comments. So you can comment multiple things between these two symbols. So don't focus too much on the syntax, just like focus on the concept of it. So when I'm commenting, I'm basically disabling this code from running. So the underlying engine will not pick this code up. So here you can have multiple lines of code, and you comment all those lines at one time. So this code won't run anymore. Cool. And I can uncomment it by if I just remove this, then it will start working. 100, 123. So I'll just like comment this. So we did logging and commenting. Now we'll come to the most important aspect of coding, which is data. Right. So like when it comes to programming, like I said, input is where it all starts. And input basically gives you some data. And now you need a way to store that data somewhere, right? And that the where you store the data is called as a variable. So we'll create a variable. So the syntax to do that is var for variable. So you create a var and then you can name it anything. So I can call it a, which is the name of my variable, and I'll set it to 1. Right. So if you just look at this line, a you can think of as a box, like a container, where you're putting a value 1 inside of it. Right. So now if I print this value to console, so console.log, and then I pass it a, right? So what you'll expect 1 to come here, right? So we got 1. Let's comment this one. So I stored my value of 1 here, and I was able to reuse it at a later point in my code. So now, what do I mean by a later point? So code run line by line. So first this line gets executed, then this line will get executed. So when I do this, now I've put this value of a in my memory, and now I'm accessing it from my memory and printing it to my output. Right. Cool. So this type of, so when I say data type, this a is now set to number type, right? And I can do that. I can check the type by saying type of, which is basically a way to get the type of that number as number. Right? So number is one type of data. So if you look at Airtable or any other thing, so I'll just quickly open Airtable. So you can come here and see the different types that exist. Right. So they are derived or higher order types based on these primary data types. Right? So your primary data types are number, string, boolean, uh, null, and undefined. And then these are all built on top of that. So you have number here, you have text here. Long text is like a larger, you can store more amount of text in that. Phone number is a specific kind of text. Right? So these are like derived data types which are most useful when you're using, which is why it's no code, because it lets you think easily in those terms. But here you go one step below and only think in these primary data types. So like we'll just think of 5: number, string, boolean. So so what is a boolean data type? So boolean data type is of like I call it b equal to true. Right? So it can have two values, true and false. So true means on and false means off. True is 1, false is 0. So now if I log console.log g, I'll be able to see this as true. Now we'll come to how you use these variables later on, but right now we just define some variables. So we can call this as max. So this is like, and we can like these names don't need to be this. You can name them anything. So I'll call this name as max, and I'll just log name. So you get max here. So the reason to think in terms of variables is now, let's say I had to do something like this. So I have to log this name multiple times in my code, right? So if I don't use my variable, the way I would go ahead is I'll do something like this. And then I'll copy paste it here. Like let's say after 3 days I come back and I have to change something. I have to change it to this, and I forgot to change one of them, and now there'll be some problem in my code. So using a variable, what happens is I just have to change it in one place, and then it changes everywhere, right? So this is a problem-solving technique where like variables help you not repeat yourself and like remove redundancies a lot, which can help you with database design as well. Cool. So we got like 3 data types down. The fourth one is called null. So null is just like the value is null. So when you set it to that, it basically says that C has been intentionally like it has no value, which is useful when you have to unset something or set or something doesn't exist. The other last data type is undefined, which basically means that null I'm intentionally setting it to like not have any value. Undefined is like by default it has no value. So for example, if I go to Airtable and like this recommended by has no value right now, I've not entered anything. Right? So this will be undefined by default because I've not given it any value. But if I have to give it a value, I can set it to none. So yeah, so there's like that intentionality is important in these. Cool. So that's the variables. Any questions or?
It doesn't seem like we've got any questions, but if someone does, feel free to come off mute. And ask away if you do have them.
Awesome. Cool. I'll continue. So the next thing is like, okay, so we are able to define some variables and we know what data types are now. The next thing is like, what can we do with those variables? So one thing that you do in like, we'll start always with math. So one thing you can do is like arithmetic operations. So here I can say 1 plus 3. So this plus is an operator. And this operator is like a sum operator. So now the sum value is basically, so this 1 plus 3 will be evaluated first. So this will be 4. And this is an assignment operator or equal to. So this value will then be assigned to this sum value variable. Right? And I can do like console.sum. It might seem very trivial, but like this idea is important of like what's happening here. So you have a math operator here, and then you have some like literals, and that is assigned to a variable. Now, so we covered, so this is, so what are the other types of arithmetic operators? So you have minus, you have multiplication, division, you can do square root, so you can do like square. So yeah, so there are a lot of those. And we'll cover a math library which lets you simplify like these things. There are a lot of functions written. Where you can do square root, you can do power and all those things, which will be useful when you actually have to modify some data in your table or any other place. But yeah, like, so the two things are assignment and arithmetic operators. then the so yeah, now we know how to do maths. We know how to define variables. Next thing is like the control flow. Like what is control flow? So like I said, so when a program runs, it runs from top to bottom, line by line, right? Because it's a scripting language, it's running from top to bottom. So what if I want to branch something? So let's say I have this where equal to 3, equal to 5, equal to 10. So now what I want to say, like an if then else. So if sum is greater than 10, then I want to log high, right? And if it's less, then I want to log low. So, so this is what is basically a conditional. And what I've done, which might not seem obvious because like the code is written in a linear way, but basically you've created a branch, right? So the code starts running like this, and then it goes here, or it starts running like this, and then it goes inside here, right? So you've basically created a branch, and then you continue on from there, right? Or if you want to do some other things inside this branch, you can do it. So this is how you branch your code running, and you can basically do decision making, right? So this is super critical. So so let's say I'll define if it's Sunday, I want to give out a greeting, and like I can cover only small examples in the demo. But if I run this now, it'll print. High. Yeah, it'll print low because yeah, this is greater than. So one thing when you think of like if conditions is like how are you actually thinking of conditions? So there are comparative comparison operators, right? So we talked about arithmetic, but there's also comparison operators. So here uh, you have greater than, less than, greater than equal to, less than equal to, double equal to, not equal to. Right? So these are like the operators that you use to check if a condition is true or false. So this single individual thing returns a Boolean value. So I'll show you what it means. So if I do sum greater than 9, right? So this thing will evaluate to true. So you can see the true log here. So if this is true, so if takes in a Boolean value, like so this if in the bracket, it will expect a Boolean value. So if it is true, it goes inside this curly brace code, else it will come here. Any questions on this?
I think we're all good so far. Feel free to plow on.
Right. So this is one kind of condition. The other thing might be like we might want to do and or logic, which is like logical operators. So we might want to say if so we can take like a actual use case. So we'll say salary of person A is like 3,000, and salary of a person B is 5,000, 6,000. So we can say if salary of A is greater than 1,000, these should be numbers. So yeah, so you define strings within quotes. So I missed that tiny detail. So then you do something, and then we have something called as else if. So this allows you to create multiple branches. So so salary of is less than 1,000, do this. Greater than 1,000 and less than 3,000. So now if we read this code, so it checks what the salary of A is. So it's 3,000. So this will be false. Then it comes here. So if salary of A is greater than 1,000 and less than 3,000. So and operator basically checks that this has to be true and this has to be true. So both the conditions on the left and right have to be true. In case of or, which is this double thing, either one of them can be true. Then it evaluates to true. Otherwise, it will be false if both are false. Right? Uh, so in this case, that's also not true because it's exactly 3,000. And if I do this, then it will be true because this will like, sorry. this will be true, but and this will also be true, so it will come here. So it gave mid-range as we like, because like both of the statements are true, and if I change it to 2000, we go into high range. Right. Yeah. So I mean that's I think pretty much about conditionals. You are able to do multiple else if conditionals. You can do and, or, and logical operators. And if has to like accept a boolean basically. Cool. This might so there's a shorter way of doing this, especially for like small conditions. So what we can say is range, which is what we are computing, is equal to and then here we write the Boolean condition. So the salary of A is greater than 3000. So if this is true, then evaluate what is after the question mark. So it will be like high range, and then after colon, mid range. So this is like a very shorter way of writing that same syntax. And the reason I'm telling you this is because most people use this online. So when you go to Stack Overflow or any other place, they'll write if-else conditions like this. So that like this might be important to understand. So if this is true, it will return this as the output. So range becomes this value, and if this is false, it will return whatever value is after this colon. Right? And then I can log range. So you can see it says high range. And if I do it like this, it'll say range, mid range. Right? And also I did like the string concatenation here. So you can basically concatenate two strings by adding a plus between them. And there's more to go about here. So range here is actually a number. Sorry, it's a string here. But like so there's something that JavaScript does, which is very cool, which is called as dynamic typing. So what that basically is that it will automatically figure out at like what the type of something is. You don't have to manually define, which is why it's so much easier than other languages. So if I say a equal to 344 or 340, what is it? So here like the type of a string, right? And if I set it to like 300, it will automatically know that this type is number. You don't have to mention the type. So like that's where a lot of magic happens internally. And if you give something like 3 plus 4, it knows that both are numbers, so it will evaluate it as 8. So if I run this, you'll get the output as 8. So you get 8 here. But now if I change this to a string, what will happen is that you'll get a very weird output, which is 35, right? So the reason you get 35 is it gives strings that so it converts this into string because otherwise it will not make any sense. So it automatically converts this to a string and then it concatenates the strings basically. So yeah, I mean, a small fact about how JavaScript handles these things. And these you'll end up with these bugs at some point anyways. So yeah, I thought I'd mention. Cool.
Prajot, could you just clarify when you're saying string? Could you just clarify what that means very quickly?
Right. So a string is basically a text, like what you see text in Airtable. So I can say var a equal to. Right? So this thing is a string because it's inside a code, and I'm writing some text value in.
Okay. Okay. Yeah, that makes sense.
Yeah, I mean I can go into more technical explanation, but I need to cover arrays first. But yeah, that's pretty much what it is. You can think of it as a text file.
Cool.
So yeah, I can cover switch case, but I think this is irrelevant at this point. We'll go into functions first. Right. So function, like so we already we were writing some code and then we find that okay, this code is reusable. I can do this multiple times. So I should probably make it into a function. right? So a function, like in mathematical terms, is basically like y equal to x plus 3, right? So you give a value of x and you get a value of y. So that's what a function in mathematical terms is. So regardless of the value of x, the formula remains the same, and y will always return x plus 3. So if I say x is equal to 2, y is 5, x is 7, y is 10, right? So similarly, function coding has a similar like usability. So I created this function called as sum, and the way you think about declaring a function is so one is the definition of a function. So it always starts with the function keyword, and then you write the name of the function. So add, and then you give the arguments. So or parameters. Basically, what is the parameter that this will take? So I'm creating a function that can add two numbers. So I'm giving it number 1 here and number 2 here. And then finally, I have to return an output value. So in this case, it will be num1 plus num2. So now this function takes in two parameters as input and returns this output. Okay. So if I do this, add 3, 6, it will return 9. Log it. So you can see like it gave 10. So now, so this is where you call the function that you've created, and I can do that any place I want to later in my code. And now I've converted my 2 lines of like this 1 line of expression of code into this one single add function. Okay. So and called it any different values. And like add is a small function, so the value is not clear at this point. But now we can write a bigger function. Once we do arrays, I'll show you how this, like everything ends up becoming a function at some point. And that's how you end up adding modularity, and then those functions yeah, let you do cool stuff. So like, for example, let's say you have this phone number field, right? Now you can have a function which checks whether this phone number is valid or not, right? So you can have a function, so say function is valid phone number, right? And it takes a phone number as an input. So I'll write phone number as input, and then I'll return a Boolean value, because like, is it valid, true or false, right? And here you have a regex. So I like, and I don't remember that regex, like nobody does. So I just look for regex. And this is an important part of coding, is like you have to go to Stack Overflow and you'll find the answers to your questions. So you can just copy this. Pick up a complicated in this one. Yeah, we'll do a simple one. Yeah, is valid. We'll start with a simple one. Is valid name. So we'll check if this name is. So how do you check if a name is valid? We can say name should not be equal to none, right? And then we can return true. Else we return false. So now if I call this function, so let me just clear the console. So I gave this name, this is not null. So it'll run this code. Now what I have to do is like, I can again copy just like this is valid number instead of the whole code that I wrote before, all of this. And I can set it to a different value, right? And this time it will give false because it is none, right? So it comes here, this value is none. So null is not equal to null. That's not true. So it will come here and return false. Right? So I can keep using this name wherever I want. And a good use case is like in a sign up or login form where you capture name. So you check that a user is not entered an empty name. So true for this, false for this, and true for this. So that's like a very basic thing about functions.
Can I, before we move on, Prajot, got a question in the chat from James, a couple of questions. So one on, do you think it's important to learn HTML and CSS before JavaScript when building with no-code tools?
I mean, it helps because like when I learn a no-code tool because I know HTML, CSS, and JavaScript, like I can learn them at a much faster pace. Uh, Also, it just like it's obvious to me what's possible and what's not. So I don't focus on the tool and I focus on what I have to make. So it surely speeds up the process of going through the tool. The other question is like the tools where you hit a wall. So bubble is like if you look at just bare bones bubble, it's pretty plain and you can't do a lot with it. Like the plugin community around that is what makes it good. So that is all like coding, and somebody else has done that. And then you have to rely on what the plugin does. And if you don't want it to do something, you can't really do anything about it. So that's where like it helps a lot.
Awesome. And then we just had one more question, and this may be one for kind of later. And actually, before I just read that out, I think Rashika gave a good answer as well on that question. So in my experience, if you're going for functionality, JS is better to learn than CSS, but CSS is great for extending your UI kind of levels of customization. So I just wanted to read that out. So thanks guys for kind of chipping in there. And then the second question, which we may breach at the end of the session, but feel free to look at it now, Prajot, is around, do you have any examples of no-code apps that have kind of hit a wall and then you were able to kind of scale it by or add some functionality by injecting JavaScript into it?
Right. So I've worked with a lot of people who like got stuck on their no-code tool and then they needed help. So one example was like in Airtable, somebody wanted to do some custom formula, which involved like picking data from multiple tables and multiple columns, and it was just not possible with like the existing thing they had. So they're like a very small script which took like 10 minutes to write was able to solve that problem very quickly. Uh, Another good example is like I've built a lot of Bubble plugins which solve problems which you just can't do with Bubble or on the existing plugin marketplace. So that's kind of where. And Builder is like lets you do a lot of JavaScript. It goes into that zone where if you know JavaScript, you can pretty much build your own no-code tool on top of Builder. So that's like awesome. So yeah, I mean, I think as more and more I see like it's becoming more clear that if you know JavaScript, you can do crazy stuff with these tools.
Awesome. Yeah, brilliant. Yeah, thanks for answering those. Yeah, I'll let you know if we have any more in.
So like just like I just saw time, so we are like close. So I'll just focus on the more important stuff now. And one of the most important stuff, like I said, in coding is data. So we need to cover more data structures. So one of the most part data structures is arrays or lists. And most of the web is just basically a list of things. And the way it is done is it's stored in an array. So an array is basically defined by these square brackets. And then you define a list of items inside it. So here we have an array of lists of strings. So I can have multiple names there. So like now this array is of size 3 and it has like these names. Right? So now I can do stuff with the this array object. So I can do length. So this gives me the length of the array. And then I can do I can fetch a part of the array, and all like array indexing starts at 0. So this is 0, this is 1, this is 2. So I'm fetching the 0th element of an array, and then I'm fetching the first element. Right? So if I run this, I'll get 3 as the length of the array and then like the names. Okay. Right? So like now if you look at what an array is in a table, so in a table, one column or one row is an array, right? Uh, and then you have multi-dimensional arrays, which is like an array of arrays, right? So I actually have a good example of that already. Right. So you have like a outer array, and then you have like these arrays. So if you look at it, this actually looks like if I add some spacing here, this will start to look like an Airtable, like a table, and that's pretty much what it is. Uh, So now to access this kind of an array, what you have to do is like very similar. So I'll say people, and then I need to get, let's say the second, like I need to get like this row, right? So 0, 1, 2, 3. So I need to go to the third index or the fourth row, and inside that, let's say I want age, right? So that will be 1 for like 0, 1, 2. So yeah, so I mean all arrays they start with 0. So this is an array and then this is an array. So I go ahead and do 1. So this will give me the age of this. So the value I'm expecting now is 36, right? And I can also get like, if I do this too, I'll get male. So now we've learned like, so this is how we define an array, this is how we define a multi-dimensional array, and this is how we access the values in the array, right? But this is tedious, right? I don't want to go to one of each and then write a program where, okay, I want to calculate the sum of all the ages, and I have to go one by one. So what you can end up doing is like loops, right? So array and loops, they go really well together. So now what is a loop? A loop is basically an iteration over an array, and then you can do stuff combining them. So it starts with a for. So for is a loop. You define a variable and we generally use I as a variable to do the counting. So where are we right now? So I equal to 0. And then how long do you want to run this loop for? So I'll just write 10 for now. And how much every step the array is like this loop should increase. So I will be 0 during the first run of this. During the second run, I will be 1 because I've written I plus plus, which is equal to like increase it by 1. So if I do it like 2, then it will increase it by 2 every time. And as soon as I reaches 10, it will stop running this loop. Right? So yeah, that's just like you're running this code multiple times. So if I just log the value of I, you can see this. So you can see 0, 1, 2, 3, 4 till 9. And when it became 10, it just stopped and moved out of this loop, right? So you're making the code go, iterating it there. So now if I change it to I plus equal to, what you will expect is this will start at 0, then it will be 2, then 4, then 6, then 8, and then it will stop because it became 10. So now what? So I'm able to like now run a code multiple times. So whatever is inside this is running multiple times. So that's like the takeaway. So now if I want to run over this, I don't want a hard coded condition, like it shouldn't be prefixed. I want to do it for people.length. So like I want to run it for as many times that there are people. So I can just get like the length of this array doing dot length. And I want to run it for 1. And now I can just do people of I. Right? So what this will print is like this array will print this first and this first and so on. So I got like these separate arrays printed here. Right? So I'm printing like the rows of my Airtable basically one by one or an Excel sheet. Uh, but now if you want to go deeper and print each of those individual values, they are also an array. So I can do what is called as a nested loop. So I'll define a new counter. And then I'll say, okay, this has to be of length. So people of I, which is like that value of that array, dot length. So now I want to learn it for the length of each of these. And then I can say, and now you can like I showed here, you are doing 3 and 2 here manually. Here you don't need to do that manual. It will automatically keep changing as the values come. So let me just play this and then I can explain. comments also. Right. So if you look at this, it's printing the name. So what happens is I equal to 0, it comes inside. J equal to 0, it will come inside. So first it will print people of 0 and J of 0. So it will come into this first, and then it will print name. So we get name first, right? And then it will not go outside. It will keep I equal to 0, and then J becomes 1. Right? So it will print age now. So 0 and then 1. So that will be age. And then it will go to 2. So it will print gender. And then j is less than length. So the length is actually 3 because there are 3 elements in this array. So now j becomes 3 because 2 we have printed. So it will break out of this loop and then it will go into the above loop, and then I becomes 1 this time. So now the same process is repeated for this. So this is super important if you're working with any kind of table data structure to understand how nested loops and loops work. Because then what you can do is now you know where you are, right? So you can say, okay, so if j value is 1, right, which means all the age values, then you can do some interesting stuff there. So if j is less than 30, then create a new column at the end of it and call that person as like a Gen Z and the other one is Gen Y or whatever. So I mean, you can do a lot of cool stuff. So this is how you read an array and then do stuff inside here. Cool. So that's looping. Uh, and the final thing I want to cover before we run out of time is objects. Uh, So the one thing about arrays which is very weird is that you have to index it using numbers 0, 1, 2, which can become abstract. So there is something called as dictionary or objects in most programming languages. So here we'll define one row of what our people data structure is person, and our person will be a dictionary. So a dictionary you can think of as key and then you have value, right? Like a normal dictionary. So you have a name as the key, and the value is the value of that person. So value of that key basically. And then you have age, and then age in this case is this. And gender. So now this is much more readable. You know that this is person, it has a name, age, and gender, and these are the values. Right? Now, how do you access these values? So you say person, and then you use a dot operator. Right? So you get like age, gender, and name. So I can say person dot name, and then I can do some concatenation here, like the string concatenation we talked about. Age. So now if I log, it will print match 26 male, right? So now this is a much more readable code. It's easier to understand what's happening. You don't have to understand what I is, what j is, what numbers are. Right? So this is what so one is like the expressivity of objects is great, but the objects are even more awesome. So what you can do is you can have now an array of objects or objects of array or whatever you can imagine. So let's make a new people object, which is an people dictionary, we call that. So this will be an array because I want to have multiple people in this, but each person in this will be an object instead of an array. So what I need to do is I'll create like this. So that's one person, and then I'll add one more. So now I have like these two people in this people dictionary. So this now starts looking a lot more like, right? So you have name as this, points as this, votes as this. So here you can say name is this, age is this. And now you can do a for loop over this array of people dictionary. So hopefully what I'm writing is making sense now. I plus plus. So I'm looping over this dictionary till the length of the array. So that will be 2. And here I can just do console.log. I. So whatever the I value is, dot name. So here I don't have to worry what name is. It can be in any order, and you get like, and then I can do. So you can see here max 26 public 32. Right. So now this code is much more understandable. And when you now if you call an API or you look at the output of Integromat or Zapier or any kind of APIs, they are mostly array of objects. So this data structure is called an array of objects. And so it's generally like of this nature. So you'll have an array and then you'll have like this object with multiple values and then yeah. So now one cool thing about objects is it doesn't have to be like just strings, numbers and booleans. You can have an array inside of this. So I can have here as skills, right? And these skills can be so you can have now array and like you can keep nesting it as much as you want. Cool. Sorry. So yeah, I mean, you can just keep going on with this. You can add another object inside another object and so on. So yeah, I mean, if you understand like the basic variables, you understand arrays, you understand objects, and you understand array of objects, you can pretty much now when you go into Integromat, Zapier, or any API, the output will start making a lot of sense. So we just look at one API. Right. So now we're looking at this data structure, right? So this is a weather map API. So now you can see that this is an object, right, of JavaScript. So JSON is pretty much very similar to JavaScript. So this is a key called, and that is again an object which has a long and a latitude as the keys, and these are the number values of that. So if you set this object to weather, right? So this is the higher level object. I'll just copy this. I can set it. So weather into this, right? So now if I have to access like the longitude of it, right? So what I can say weather dot chord, right? Because this is how I access the key of a dictionary. Dot longitude. Right. So this will give me 80.35. Right. So now when I look at the output of the response, I can get access. So if I have to access this, let's say description of the weather. So I can say weather dot weather, and then it will be dot. So you can see it's an array of object, right? So you have to access the 0th element. So you can do 0, and you can say dot description. So we say scattered clouds. So yeah, I mean, so once you, so yeah, this is like the most important data structure like objects. And there's a lot more I would like to cover, but we have a second workshop, so yeah, I'll stop now.
Yeah, thanks so much, Prajot. This has been super insightful. Yeah, maybe we've just got a couple, if we have a couple of questions and then wrap up. So maybe, yeah, if anyone has questions, feel free to come off mute and just ask away before we close up. But yeah, yeah, go for it, guys. Maybe if we could stop sharing screen and then just so we can see people. Yeah, perfect. Awesome. Yeah, does anyone have any questions before we close up? Let's just see. Go to gallery. If not, that's absolutely fine. We're going to have a second installment of this workshop next week, same time, same place. So could you just share a little bit more about what that second one is going to entail, Prajot?
Yeah, I mean, I think we covered less than what I would have liked, but yeah, it's just hard to cover so many things in a single session. So next time we are actually going to build Airtable scripts using the concepts we've learned today, and we'll go into like a couple of concepts which I missed. So yeah, so in the next session we'll be building actual Airtable scripts.
Awesome. Yeah, I think that's, yeah, people seem to be chomping at the bit to be able to do that. So yeah, excited for that. Well, thanks so much, Prajot, for your time and everyone here today, and hope to catch you next week. And in the meantime, see you on Slack. And I'll be uploading the recording tomorrow, so you can kind of dive into bits that you want a second look at. So yeah, thanks guys, and speak soon. Yeah, have a good one. Bye bye bye.